So there's my forces and constraints. For my mesh,
Will you hold on 1 second?
sure.
What geometry do you need?
For geometry, you're doing a surface, and then you pick XYZ. Yeah, and then just type in 4 space 1 under vector coordinates.
What is called
Okay, so now for meshing, you're going to do mesh seeds, uniform, number of elements. We want to set that to 1. And turn off auto execute. And we're going to select this edge. So it's surface 1.1. Hit apply. And then we want to change it to 5. We could change it to any number. It could be 10, it could be 2, it could be 100, whatever we want. But remember, we're doing mesh seeds here. So I'm going to select this surface, which is 1.4.
So the more we do, the more accurate the results are, though?
Mm-hmm. Yes.
But there's a limit to how big we go.
Well, there's a point of diminishing return in that with 5 nodes across the bottom, we're going to get a fairly coarse result. Once you get up past 100, I don't know that for sure, but I'm going to say after you get past 100 nodes across the bottom, if you have 1,000, 1,000,000, the result is, again, the change in result will be so insignificant that it's not worth the computing time.
And we've just been using 1 to keep it simple.
Prior to what we've been doing today, our elements have been 1D,
Okay.
one-dimensional.
Okay.
So let's see. So now we want to put a mesh on this. So we go to measures and we pick surface. So remember, the mesh seeds are just telling Patran where to put the nodes for our. Okay, so we want to create a mesh on a surface. We're going to do element shape is tria for triangle, and iso mesh, and we want 3 nodes per. To see if you pick here, you can do 4, 6, 7, 8, 13 nodes per triangle. Then when you go into the iso mesh, select this bottom right. I mean, you can pick any one, but we're going to work with the bottom right one. And iso, for your surface to be iso, it just means that you have equidistant sizing for your nodes. And let's see, that calculation doesn't matter. So we're going to surface 1, so we hit apply. So there's our mesh of triangular elements on our surface or our beam.
Have you ever had it where the program won't let you type the letter C?
No.
Okay. Everything else on my computer is letting me type it, but it won't let me write surface because it won't let me do the C. It clicks out of it.
That's weird. I don't know. So now that we've gotten all this, we can go to analysis, entire model, apply. Yes, actually, oh well, too late. Bless you. So then we want to pick up our results and go to, we'll just do deformation. So displacements, transitional, apply. So this was 2.53, so we should write this down. So our first trial with, what we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles.
Why doesn't his look like ours? Hey, but why doesn't yours look as fancy as ours does?
Oh, because I picked, well, here, I'll make it as fancy.
Oh, you picked the defamation one?
Yeah,
Fun.
there you go. How's that? Does that make you feel better?
A lot.
See the pretty colors?
Yeah, pretty much.
I mean, I was promised.
Do not be enticed by the pretty
I
colors.
promised it'd be
They're
promised
wrong.
pretty pictures at the beginning of the class,
Yeah.
so this is looking better.
Okay.
That's interesting.
All right. So we got our deflection or our max deflection. So let's see. So I want to clear this.
Really small number, right?
What's that?
That's a really small number.
2.5 times 10 to the minus third.
So that's pretty good.
So
right?
it's 2 thousandths.
Yeah.
So it's not very much, but we calculated that it should be 8 thousandths.
Okay.
So it didn't give us a very good result. So if we go back to mesh, and let's see, I want to remove or delete my mesh. So apply.
So when we put our load of 1,000 pounds on there, then on the surface,
Oh no, I got rid of my nodes. Whoops. Oh well, I can put them back. Say again, sorry.
when we put the load, when we input the load, then when we're doing a surface like this, it puts it across the whole surface.
Well, the load I put in for this example was just a point load.
At 0.12, right?
But we want to put it, I'll figure out how to do a surface load.
Okay.
Is that why you said it was a
I
little
see. Right.
So it's adding a bunch of nodes to mine.
What's that?
So adding a node over.
So
Okay.
did you click on mesh seeds and then that's how you deleted everything?
No, while I was on Mesher and I hit delete and I picked everything, I should have just done a window inside to get rid of the mesh, not the nodes too. Okay, so let's see, I need to create my surface again. Okay, so now this time instead of doing 3 nodes per triangle, we'll do 6 nodes per triangle. And we're going to surface 1, so we'll hit apply. And it doesn't, but anyway, there's 6 nodes on there. So we should be able to go back to analyze. Now that I've created that, I'm just going to write over top of everything. Say apply results. So if I go do my deformation and apply. So now I got 8.93. So that's pretty close to what we calculated by doubling the number of nodes on the triangle. We didn't even increase the number of triangles, we just
Oh, darn it.
increased the number of nodes on them.
Okay.
I changed my number to 6. Is that not what you did?
For Tria 6, yeah, that's fine. Oh, you did 6 nodes across the bottom? Yeah, that's fine. That's okay. So let's go back and we'll try quads this time. Maybe I'll not try to delete everything this time.
I tried to just make it in the middle and it deleted it.
Yeah, see here you can see the node, the additional nodes on the triangles. Okay, so is that just getting rid of? Well, I should probably just do that. I know I'm not screwing anything up. Okay, so we'll go back. Put file on the bottom, on the top. Okay, so now I want to do a surface mesh. This time, instead of picking Tria, do quad. And we're going to do quad 4, surface 1, and apply. So there's my quad elements. Now I can go back and analyze again. Oh, I forgot to write down the number last time. It was 8.94, wasn't it? Something like that, anyway. Okay, so we're done with analysis. Apply.
Was the topology
That one's, which one?
And hit apply.
Features and then
This?
Oh, they already applied the
well, he
results.
wasn't, he wasn't trying,
Yeah, no. What
and
did
he
we
went up to more, and where he's applied for.
I'm not convinced those are the right results.
But I think if he,
So let's go back here.
What was the force you added again?
Pardon?
What was the force that you added on that?
1,000 pounds. Did that run? I wasn't paying attention.
I'm just going no, we got 4.
Okay, so
Oh, it's gonna turn everything. Well, like, it doesn't have a triangle.
No. Quad, square.
So see, even with the quads, I get 8.98 on the first go around.
Which is like spot on, right?
So our first result is almost correct to begin with. So let's see if we get any better accuracy by going to 8. Just delete everything again.
We went 60.
Okay, surface, do quad 8, surface 1, apply, analysis.
Yeah. Well, I did try to do the quad 60 and it's it's really yeah, it's nice.
So 8.99 for the 8s. So that's pretty close to our 8.5 times 10 to the minus third. So that's how that works. For some of our more complicated shapes, we're going to want to do slightly different scenario, but we'll get to that.